tour of Java threads and C threads. First of all, let's see why we use threads. Threads is a powerful programming tool. Computer users take it for granted that their systems can do more than one thing at a time. They assume that they can continue to work in a word processor while other applications download files, manage a print queue, and stream audio. Even a single application is often expected to do more than one thing at a time. Examples of a web server. Many clients accessing. Impossible to handle without threads. That means they handle the concurrent users without any traffic. Another example. Streaming audio application must simultaneously read the digital audio of the network, decompress it, manage playback, and update its display. Even the word processor should always be ready to respond to keyboard and mouse events, no matter how busy it is reformatting text or updating the display. Softwares that can do such things is known as concurrent softwares. Concurrent programming. The PO6 operating system standard defines a thread library that is possible to any system supporting the PO6 standard. This is used in C programming language, and the Java platform is designed from the ground up to support concurrent programming, with basic concurrency support in the Java programming language and the Java class libraries. Since version 5.0, the Java platform has also included high-level concurrency APIs in the Java util concurrent packages. In concurrent programming, there are two basic units of execution. They are processes and threads. In the Java programming language, concurrent programming is mostly concerned with threads. However, processes are also important. Threads are lightweight processors. A computer system normally has many active processes and threads. This is true even in systems that only have a single execution core, and thus only have one thread actually executing at any given moment. Processing time for a single core is shared among processors and threads through an OS feature called time slicing. Let's see what is the difference of processes and threads. In C programming language, with a fork system call, we can get another process. After creating another process, we can see that it has separate heap, stack, and data section. One process's data is unique for that process, and the other child process's data is also unique to that process. But in thread creation, if we create a thread, all the threads share heap and data, but each and every thread has its own stack. It's cheaper to create a new thread, but it's not cheaper to create a process. And context switching between threads is more faster than context switching between processes. Threads can easily share data, and processes are protected from one another. By considering all these facts, threads gives an efficient way of handling programs. First of all, let's talk about the threads in Java. Threads are built into Java as part of the standard class library. There are two ways to create threads in Java. first one is by extending the thread class, and the second one is by implementing the runnable interface. Both means of creating threads in Java require the programmer to implement the run method. When a new thread is created, the run method is executed in parallel with the calling thread. Let's look at how to create a thread by extending the Java thread class. First of all, we have to write the class. Here, for example, we take the class example. Here, the class example has extended the thread class, and the run method also has implemented. Here there are class data, and let's look at how to create a thread object from this class. By initializing thread class, we can create a new thread object. Here our class name is example and our thread name is XYZ. To start the execution of the run method to run the thread, we use the start function. That means our thread is XYZ, and by calling xyz.start we can start our thread object. The second method of creating a Java thread is implementing the runnable interface. First, what is runnable interface? Java does not support multiple inheritance. If a class extends thread, it cannot extend another class. Programmers frequently want to use multiple threads and extend other classes, such as applets. The runnable interface allows a programmer and a program to use multiple threads and inheritance. Let's look at how to implement runnable interface and create a thread using that. Here also our class name is example. Class example implements runnable interface, and the class data is also there and the run method is also there. To create a thread with the implementation of runnable interface, as we did previously, we first want to initialize our thread object. Our class name is example and the thread name is XYZ. After creating a new example object, that means our class name is example and this object is created from the class example. That's the object from that class. And to create the thread and to start the thread, we use new thread xyz.start. If critical code is unavoidable, mutual exclusion must be enforced with locks. In Java, this is done using the synchronized